Hi everyone, it's Miss Costa here, and in this video we're going to go through the June 2017 Edexcel Foundation series. Okay, so for this first question, I'm shown the lengths of 5 rivers, and I'm told to write down the rivers in order of length. So I'm going to look for the largest river first, and it might be helpful if we write them out just so that we can compare them more easier. So when I'm comparing length, I'm always looking for the highest place value first. So that would be the hundreds column. So I'm looking for the highest hundred. So that would be 354 or 346. They both have 300. Then, because they both have 300, I look in the tens value. So 5 is higher than 4. So 304 is the river Severn. That would be the longest river. Now it's saying start with the shortest river. So I'm actually going to do this in reverse order. So that would be the 5th one. Then I look for the second one, which would be 346, which is the River Thames. So that would be the 4th. And then I look once again at the hundreds column. 2 is the largest number. So 297 is the River Trent. So that would be the 3rd longest river. And then I look once again, the hundreds. Both of these have hundreds in them. Both of these have 1 as their tens unit, but 2 is the smallest ones unit, and 3 is the largest. So 113 would be the 2nd longest, and Don would be the 1st. So I have to write them in their names. So I'd say the River Don, the River Don, the River Mersey, then Trent, then Thames, and then the River Severn. Next it says, Amy says the River Thames is more than 3 times as long as the River Don. So the River Thames, if we look back, and the River Don, let's see what their lengths are. So the Thames is 346, and the River Don is 112. When it says show that, you have to show your working to show how you know that. So if it was more than 3 times as long as the River Don, we need to do 112 times by 3 and show that the River Thames is more than that. So 112 times by 3 is 336. And I know that 336 is less than, this inequality means less than 346. So that's how you can show that. You just know that 3 times the River Don is 336, and that's less than 346. Next, I'm told that cups are sold in packs and boxes. So there are 12 cups in each pack. So we've got a pack, and I have 12 cups in them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I'm told that there are 18 cups in each box. So there's a box here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You could just write 18 and 12, but just to help you visualize it. So Alison buys P packs and B boxes of cups. Write down an expression in terms of P and B for the total number of cups Alison buys. So cups are the things inside the packs or the box, and in a pack there are 12 cups. So I'm going to say however many packs there are, it's 12 lots of that. So an expression for that would be 12p, because I'd be doing 12 times by the number of packs. And in algebra, we don't write the multiplication sign, we just put the number and the letter next to each other. And then for the boxes, there are 18 cups in each box. So however many boxes there were, I do 18 times by the number of boxes. So that would be 18b. So that would be my expression for the total number of cups. Next, I'm told that here are 4 digits. Write down the smallest possible 2-digit number that can be made with 2 of the digits. So the smallest possible number, it's always like your highest place value that you want to be the smallest. So 1, I'm going to put first, and then the next smallest digit is 5. So that would be 15. Now write down the 3-digit number that closest to 200 that can be made with 3 of the digits. Okay, so closest to 200 is either going to, well, it would either have to be 100 and something or 200 and something. So again, I'm going to start with 1 over here. And then closest to 200 is going to be the highest possible value that you can have. So that would be 9. And then the next largest value is 6. So that would be 196. Next, I'm told that 4/5 of a number is 32. So this is sometimes quite difficult because people just assume I need to work out 4/5 of the number. But if I think about it, so 32 has been split into 5 equal parts. And I know that 4/5, so 4 out of the 5 parts, are equal to 32. So then I need to find out what the number is. So if 32 is equal to 4 parts, I can do 32 divided by 4, which is 8. So each part is worth 8, and therefore the number must be 40 because I add all of the parts together. Next, I'm told that a path is made of white tiles and grey tiles. 1/4 of the tiles are white. So 1/4, 1 out of every, let's assume this is white, and then grey can be this. So 1 out of every 4 tiles is white. Therefore, for every 4 tiles, 1 must be white, and the remainder would be 3. So 1 is white, 3 are grey. Therefore, the ratio of white tiles to grey tiles would be 1 to 3. Common misconception is that it's 1 to 4, but 1/4 means that 1 out of every 4 are white, therefore the remainder is 3. Okay, I'm then told a path is made of white tiles and grey tiles. 1/4 of the tiles are white. There is a total of 56 tiles. Okay, so I know that there's a total of 56 tiles, and I know that 1/4 of this are white tiles. So to work out 1/4, I can see that this 56 has been split into 4 parts. So I'm going to divide by 4 to work out what one part is. So 56 divided by 4 is 14. So I know that one part is worth 14. Therefore, to work out what 3 parts are, I would do 3 times by 14. 3 times by 14 is 42. And to double check that I've done it right, 42 grey tiles. 42 plus 14 must add up to 56. So double check. Am I right? 42 plus 14 equals 56. So I know I'm right. Next, I've got a list of numbers, and Bridget says to work out the median, you find the middle number. So the median of these numbers is 17. So she's kind of correct, but she's not fully there. And what is wrong with her method? Well, the numbers need to be arranged in order of size to find the median. So whenever we're finding the median, we always first put the numbers in order of size, and then it's the middle value. Now here's a list of numbers, the same numbers, work out the range. So to work out the range, I always identify the highest value and I subtract the lowest value from it. So I'm trying to find the difference, the distance between the highest value and the lowest value. So the highest value here is 22 and the lowest value is 12. So I do 22 take away 12, so the range is 10. Over here, I now need to work out the mean of the numbers in the list, and I've forgotten what they are. So 12, 15, 14. So 12, 15, 14, 17, 22, 19 and 13. So to work out the mean, all I do is I add all the values together and then I divide by the number of values that there are. So remember, this line in the fraction means divide. So I'll add all the numbers together. So I'm going to do 12 plus 15 plus 14 plus 22 plus 19. So 12 plus 15 plus 14 plus 17 plus 22 plus 19 plus 13 gives me 112. And there are 1, 2, 3, 4, 5, 6, 7 numbers. So I divide by 7. Divide by 7 and I get 16 as my mean. Next, I'm told that Pretty is going to have a meal. She can choose one starter, one main course from the menu, write down all the possible combinations she can choose. Now, when we have a combinations question, you can write out the whole word, but you can also shorten it. So for instance, salad, I could say is S, fish is F, and melon is M, and then that would be P, R, and B. You can just shorten it to make life easier for yourself. So we start first with the salad. I could have a salad with a pasta, a salad with rice, or I could have a salad with a burger. Then we move on to the fish. So I could combine a fish with pasta, a fish with rice, a fish with a burger. And then my last options would be a melon with pasta, melon with rice, and melon with burger. So 9 combinations in total. To double check, you might just want to think to yourself, okay, each of the 3, so I have 3 starters and I can combine them each with 3 meals. 3 times 3 is 9. So that's just a way that you could double check if you've got the right amount of combinations. Next, I'm told that Joanne wants to buy a dishwasher. The dishwasher costs £372. Joanne will pay a deposit of £36. She will then pay the rest of the cost in 4 equal monthly payments. So a deposit is like the initial spend that you make. So sometimes you can't afford to buy something outright because you don't have enough cash. So you pay a deposit to secure that purchase. So the deposit is just the initial bit of money that you pay. So it costs £372 and she pays a deposit of £36. So she's paid that £36 off, so she doesn't need to pay it again in the future. So we can work out how much is left after the deposit. So we do 372 take away 36, which means she has £336 left that she needs to pay. She will then pay the rest of the cost in 4 equal monthly payments. So she needs to split 336 into 4 payments. So I'm going to divide by 4. And that is £84. So that is how the cost of her monthly payments. So remember, deposit is the initial spend. You place it down to hold your purchase, and then the rest is what you split into monthly payments. That's how a lot of people buy phones these days. You pay an initial deposit and then each month you pay a certain amount, or cars, any kind of high value item. Okay, so here I've got a time question. So I'm told that Davos is a cleaner. The table shows information about the time it will take him to clean each of the 4 rooms in the house. Davos wants to clean all 4 rooms in 1 day. He will have breaks for a total time of 75 minutes, and he is going to start cleaning at 9 a.m. Will he finish cleaning by 4 p.m? Okay, so if he starts at 9 a.m, and let's say he does the kitchen, that would take him to 11 a.m. So 9 a.m. plus 2 hours is 11 a.m. So that's the kitchen done. Then let's see, you always with time, you want to make your life as easier as possible. So let's choose the bedroom next, 1.5 hours, because that's easier. So he could start at 11 a.m, add on an hour and a half, would take you to 12:30 p.m. So that would be the bedroom done. Then 12:30 with 45 minutes. Remember, in an hour, you can almost split it into quarters. So a quarter of an hour is 15 minutes, half an hour is 30 minutes, 3/4 of an hour is 45 minutes, and the full hour is 60 minutes. So 45 minutes would take me from 12:30, so over here, half an hour round plus 15. So 12:30 to 1:15 p.m. That would be the bathroom. Now, 1 hour 40 minutes or 75 minutes. So first of all, we might want to convert 75 minutes into hours and minutes. So I know that 1 hour is 60 minutes. So I know that 75 minutes would be 1 hour and 15 minutes left over, because 75 take away 60 is 15. So perhaps I do that next. So I give his breaks. So his breaks can start at 1:15, add on 1 hour would be 2:15, add on 15 minutes would be 2:30 p.m. So that's all his breaks done. And then the last thing I'd need to do is the sitting room. So 2:30 p.m. plus an hour would take me to 3:30, and then plus 40 minutes. So 3:30 to 4 would be an hour and a half, and then 4 plus the 10 extra minutes would be 4:10 p.m. So that would be for the sitting room. So sadly, no, he finishes 10 minutes later. Okay, next we've got there's a few ways you can approach this question, but I'm told that ABC is a straight line and the length AB is 5 times the length of BC. So this length here is 5 lots of this length here. Now, whenever we don't know the value of something, we can always use algebra. So if I call this X, I don't know what the value is, I can then compare AB to it, because I know that AB is 5 times the length of BC. So if X is BC, I know that AB is 5 lots of X, which is 5X. Now I'm told that AC, so this whole length here, is 90 centimetres. Work out the length of AB. So if I know that 5x plus x must equal 90 centimetres, I can form a little equation for myself. Then I can simplify. 5x plus x would get me 6x. So 6x is 90 centimetres. So I could work out what x must be by doing 90 divided by 6. So I divide both sides by 6, and that gives me 15. So I know that x has a value of 15, and I know that AB is 5 lots of x. So I'm going to do 5 times 15, which is 200. Oh, no, 5 times 15 is 75. So the length of AB would be 75 centimetres. And does that make sense? Well, if that's 75 and this is 15, does that add to 90? Yes, it does. Okay, next I have to work out the value of t when v is 2. So this is a substitution question, and it's always really helpful to actually write down what the formula means. So t equals 4v, and 4v, when a number and a letter are next to each other in algebra, it means they're being multiplied. So t equals 4 times by v plus 3. And you might just want to put it in brackets just to indicate that that's what you do first, because using BIDMAS, you always do multiplication first. Well, before addition anyway. So I know that v has a value of 2, so I could write that as 4 times 2 plus 3, and 4 times 2 is 8, and then 8 plus 3 is 11. So t would be 11. Then I need to make v the subject of the formula. So when I make something the subject of the formula, it means I want to get it in the form of v equals. At the moment, t is the subject of the formula. So what I do is I can put my finger over the v, so put my finger over 4v, and then look at what else is left on that side of the equation. I've got a plus 3. So to move anything from one side of the equation to the other, we do the inverse operation, the opposite. So the opposite of adding 3 is taking 3. So the reason I do this is because it cancels on this side, so I'm left with 0. But because equations have to be balanced, whatever you do to one side, you have to do to the other. You can think of them as scales. Like if you take a weight off one part of the scale, you have to take the same amount off the other, otherwise the scales will tip. So therefore t minus 3 must be equal to 4v. Now, what does 4v mean? Well, 4 times by v, because when a number and a letter are next to each other, it means they're being multiplied. So the inverse of multiplying by 4 is dividing by 4. So that would cancel that out on this side, and then I'd be left with t minus 3 over 4 equals v. So I've got v on one side by itself, so it is now the subject of the formula. So I say v equals t take 3 over 4. Okay, next I've got a diagram that shows a cube of side length 2 centimeters. Vera says the volume of any solid made with 6 of these cubes is 48 centimeters cubed. Is Vera correct? Well, first let's work out what the volume of one cube is. So to work out the volume, you either just multiply width times height times by the depth, or you can just work out the area of the front face. So the area would be 2 times 2, which is 4. And then this is multiplied by 2. So for cube 1, I do 2 times 2 times 2. So 2 times 2 is 4. And then I times it by 2, which is 8 centimeters cubed. So I know the value of 1 cube is 8 centimeters cubed. So therefore 6 cubes would be, what do I multiply 1 by to get to 6? I multiply by 6, so I have to multiply the other side by the same, because if I have like 1 cube, and this cube I know is worth 8 centimeters, and then I have 6 lots of it, I essentially have 6 lots of 8, and that's why I'm multiplying. So 8 times by 6 is 48. So 48 centimeters cubed. Yes, Vera is correct. Okay, draw a cuboid that can be made with 6 of these cubes. So remember, the cubes have dimensions of 2, 2, and 2. And I want to draw a cuboid. So a cuboid is basically a 3D rectangle. So a cube is where all of the sides are equal, and a cuboid essentially looks like a 3D rectangle. So I can use 6 of these cubes. There's a few things you could do. You could either think to yourself, okay, I'm just going to line up the 6 cubes. So 1, 2, 3, 4, 5, 6. And then that would form this cuboid here, which would be 2 times by 2, 4, 6, 8, 10, 12. And times by 2, because I've just got 1 cube. I don't know why I made it so long. That looks a bit weird. But that could be one option. So one option for my cuboid could be 2, 12, and 2. Another way I could arrange them is if I put them kind of like arranged on top of each other. So here's 1 cube. And I could do it kind of going down like this. So I could do 6 cubes going down. So 1, 2, 3, 4, 5, 6. So my cube could look like this. That would be a side length of 2. That would be 12 because there's 6 lots of 2. And then a dimension over here would also be 2. Or I could decide to chunk them on top of each other. So I've got 1, 2, 3 down here. So 2 lots of 3. And then I could put them on top of each other like that. So it forms a cuboid that looks like this. So if they're all 2, that means that the base would be 6. There's 2 lots of the cubes here, so that would be 4. And the dimensions are still 2. Okay, so now we have to work out the surface area of a chosen cuboid. So you obviously can choose whichever cuboid you've drawn, but to work out the surface area, you imagine like a cuboid, like a box that you get at Christmas. You just dip it in some chocolate, okay? The whole thing, you submerge it. So you want to think, what are all of the different faces that are now covered in chocolate? So generally with a cuboid, you're going to have the front and the back and they are going to be equal. So the front would be this part, and if you think about it, the back would be equal to this. So let's have a think about what those dimensions would be. That would be 4 times 6, okay? And I've got 2 lots of them. So 4 times 6 is 24, and I've got 2 lots of 24. Then I might look at the sides, and I've just accidentally ruined part of the cuboid. Okay, so the sides over here, this side and this side. So I've got side and side, and they're going to be equal. So this side has a height of 4 and a width of 2. So 4 and 2. And 4 times 2 is 8. So that would be 8 and 8 that I have to work out. And then the last part would be the top and the bottom. So imagine you've dipped it in chocolate. All of these faces are going to be covered in chocolate. So you've got your top here. And sometimes my iPad just likes to shut itself down. So let's just redo that. So top and bottom. And then what are the dimensions? So over here, I've got a side of 2. And over here, I've got a side of 6 because all of the opposite sides of rectangles are always equal. So 2 and 6. 2 times 6 is 12. So in the end, what I have to do is work out the area of each individual face. So work out the area of each face. And then what you do is you add all these areas together. So let's do that. So I've got 24 plus 24 plus 8 plus 8 plus 12 plus 12, which equals 24 plus 24 plus 8 plus 8 plus 12 plus 12, 88. And because it's area, I'm still dealing with area. It's going to be in centimeters squared. Okay, next I'm told the size of the largest angle in a triangle. So let's just sketch a random triangle. I'm just sketching it so I don't need to worry about how big it looks. So the largest angle is 4 times the size of the smallest angle. The other angle is 27 degrees less than the largest angle. Okay, work out in degrees the size of each angle in the triangle. So step 1, I need to remember that angles in a triangle sum to 180 degrees. Step 2, I don't know what the value of the smallest angle is, and when I don't know a value, I always just label it X, okay? So I can say that the smallest angle is X. Therefore, the largest angle is 4 times the size, so the largest angle is 4 times by X, so that would be 4X. And then I know that the other angle is 27 degrees. So I'll call it the other angle. Is 27 degrees less than the largest angle. So the largest angle is 4X and this angle is 27 degrees less than it. So I have my expressions for all 3 angles. And I know that all angles in a triangle sum to 180. So the smallest angle plus the largest angle plus the other angle must equal 180. So I've formed an equation for myself. Now what I need to do is simplify. So x plus 4x plus 4x, 4 plus 4 is 8, plus 1 is 9. So 9x, take 27, equals 180. And I'm just going to get rid of some of this so that we have space. So I know that 9x, take 27, equals 180. So I'm trying to work out what the value of x is. So I can add, remember, put your finger over the x first, just to see what else is left on that equation. And we always do the opposite. So minus 27, if I add 27, it cancels, and I have to, whatever I do to one side, I have to do to the other. So I'm left with 9x equals 180 plus 27, which is 207 degrees. So therefore x is going to be 9 times by x, and the inverse of that is dividing by 9. So I divide both sides by 9, and 207 divided by 9 is 23 degrees. So I know that the value of x is going to be 27 degrees. So I can write that here. Therefore, 4x is going to be 4 times by 23, which is 92 degrees. And the other angle is whatever the largest angle is, take away 27. So 92 take 27 gives me 65 degrees. Now, to double check that I've done everything right, I know that all of the angles must sum to 180. So 27, so double check. It's always good to double check your working. 27 plus 65 plus 92 equals, plus 65 plus 92 equals. Oh, and this is why it's really good to double check. So I've clearly done something wrong. 180 plus 27 is 207. 207 divided by 9 is 23. Okay, so, oh, okay. See, I wrote 27 for some reason when I should have written 23 degrees. Okay, so x is 23 degrees. I don't know why I wrote 27. That's just a weird thing to do. So then I do 23 times by 3, which is 69. No, sorry, 4x. I do 23 times by 4, which is 92. And then I do 92, take away 27, which is 65. Okay, so I just did a little error in writing that out. But now let's check 23 plus 65 plus 92 equals 180. So I have just demonstrated why it is very important to double check your work, because sometimes you just make little copying errors. Okay, Andy went on holiday to Canada. His flights cost a total of £1,500. He stayed for 14 nights and his hotel room cost $196 per night. He used Wi-Fi for 12 days and Wi-Fi costs $5 per day. The exchange rate was $1.90 to £1. Work out the total cost of the flights, hotel room and Wi-Fi and give your answer in pounds. Okay, so I know that his flights were £1,500, so that's nice and easy. I don't need to do anything there. Then what I want to do is work out the total cost of his hotel. So his hotel room is 14 times by 196, because each night cost $196 and he stayed there for 14 nights. So that would be $2,744. And then his Wi-Fi cost $5 a day and he used it for 12 days. So I do 12 times 5, which is $60. So in total, he spent $2,744 plus $60. So 60 plus 2,744, which is $2,804. So I know he spent £1,500 plus this. Now I know the exchange rate is $1.90 to £1. So if I want to figure out what $2,804 is, I need to figure out what the how I can convert dollars to pounds. So there's a few ways you can do this. Either you can do a complicated way or you can do the simple way. So you know, to get from dollars to pounds, how do you get from $1.9 to 1? So 1.9 divided by 1.9 gives you 1. So you know you divide by 1.9 to get to £1. So I'm going to do 2,804 divided by 1.9. So 2,804 divided by 1.9 is £1,475.78. Let's round it to 79. So the complicated way is you could have said to yourself, okay, what is 2,804 divided by 1.9? That is 1475. So you know that you need to times this by 1475.78 to get to dollars. So therefore you would have times this as well. You end up with the same answer. It just depends which method you prefer. And for your final answer, you just need to add 1,500 plus this. So 1,500 plus 1475.79 gives me £2,975.79. So I've just rounded it up because with money generally you round up. So £2,975.79. With money you don't have 0.798 pence. You always have two, like there's 100 pence in a pound, so you're always going to round that. Okay, now it says if there were fewer dollars to a pound, what effect would this have on the total cost? Okay, so let's say the exchange rate was $1.50 to £1. Well, what effect would that have? It would mean I divide the amount by £1.50. So his amount was 2,804. So I divided it by 1.9 to get 1,475. But if instead I were to divide it, for example, 1.5, let's just see what impact it would have. So 2,804 divided by 1.5 leaves me with £1,869. So the less money, and let's just show another example. So let's make it even smaller. Let's say 1.2. 2,804 divided by 1.2 is £2,336. So essentially, the fewer dollars to the pound, the more expensive the holiday would have been. Because essentially, if £1 is $1.90, you give a pound and you can get anything that's worth $1.90. But if £1 is worth $1.20, you get less for your money. So the higher the exchange rate, the better value for money it is for you. So yeah, if there were fewer dollars to a pound, then the total cost of his holiday would have increased. Okay, so here I've got a Venn diagram. Now this funny little symbol that I can never seem to recreate, it means the universal set. Okay, so all that means is every possible number that could appear inside my Venn diagram. So we can think of like the Venn diagram as your little universe. The only things exist in this particular universe are the numbers that are in the universal set. So all of the numbers in the universal set are odd numbers less than 30. So I can start by just writing them down so that I know what my possible numbers would be. So every odd number that is less than 30, so that would be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, and 29. Now in set A are the numbers 3, 9, 15, 21, and 27. So that's set A. And in set B are the numbers 5, 15, so 15 appears in both sets, and 25. I need to complete the Venn diagram to represent this information. So essentially, every number I've circled in pink is in the section A. Every number that I've circled in green will appear in section B, and anything that is circled by both has to appear here, because this is like it's called the intersection. It's where A and B intersect, so everything that qualifies for being in A and B. So in here, I am going to write 15, and then I can cross it out because I've already written it in my Venn diagram. Then let's start with what I would write for A. So I've got, oh, what's happened there? So I've got 3, 9, 21, and 27. And then what do I have for B? I've got, well, that uncircled itself for some reason. I've got 5 and 25. And then what I have to do is any numbers that are left over, I write on the outside. So here I would write 1, 7, 11, 13, 17, 19, 23, and 29. Okay, so anything that doesn't fit inside of your little circles, you write on the outside. Now, next it says a number is chosen at random from the universal set. So the universal set is like these numbers here. So I want to figure out how many numbers there are in total. So let's just count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 numbers in total, and probability is always the denominator is going to be your total. So what is the probability that the number is in the set A? And okay, so a little bit of terminology. So you've got this sign and you've got this sign. And I like to think of it as, this is like the shape of a rainbow, right? So you can just imagine it as a rainbow. And this means, what's the probability of this and that happening? So I call it the rainbow. And over here, this kind of looks like a valley because valleys like go down. So this is the probability of this or that happening. So when I have to do the probability of this part, I just work out what is in the intersection. And when I have to work out what's in the valley, it's what's in the set A or set B or in both. So essentially what's in everything inside of the circles. So what is the probability that the number is in set A union B? That's the terminology, the technical terminology. So that just essentially means everything in here and here. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7. 7 out of a total of 15. So that's how I do that probability question. Next, I've got simultaneous equations. So the key thing with simultaneous equations is step 1, ensure that one of your variables are equal. So over here, if I rewrite this, 3x plus y equals -4, and 3x minus 4y equals 6. So nicely, this is a nice one. Over here, my x's, so my variable of x has the same value. So that's nice because sometimes you have to actually multiply your equations in order to get that. So once you have variables that are the same, so they have the same coefficient, so like y and 4y, they're not the same because y is not the same as 4y, whereas 3x is equal to 3x. So I circle those and I think, how can I eliminate them? So do I eliminate, do I add, or do I subtract in order to eliminate? Well, 3 take away 3 is 0, so I know I'm subtracting. And then what I have to do is I have to subtract the whole equation. So 3x take away 3x is 0. Y take away, so remember that y is a single y, so 1y, take away minus 4y. So I could imagine that's the same as saying 1 take away minus 4. When you've got two negatives next to each other in between the numbers, you're subtracting, you're taking away a negative. So it's the same as adding. Like if you think about it, it's, you've got this like large bucket of ice to cool your drinks down, but you take away the negative ice cubes, okay? So the more ice cubes you take away, the warmer it's gonna get. So when you take away a negative, it's the same as adding. So that would become 1 plus 4. So 1 plus 4y would be 5y. And then minus 4 minus 6. So it always helps to actually just have a little number scale, just draw one really quickly. Whenever we add, we go up the number scale. And whenever we subtract, we go down the number scale. So I start at minus 4 and I'm subtracting 6. So I'm going to go down the number scale. So that would be minus 10. So I know that 5y equals minus 10. Now I can use all of my knowledge of solving equations to figure out what y must be. So 5y means 5 times y. So I'm going to have to divide both sides by 5 and figure out that y equals minus 10 divided by 5 is minus 2. So I know that y equals minus 2. I figured out the first part. Once I've figured out what one variable is, I substitute into whichever equation I want. So either this equation or this equation. And the easiest one is where y is going to have the lowest value. So I know that 3x plus y equals minus 4. I know that the value of y is minus 2, so I'm going to say 3x minus 2 equals minus 4. And then I can solve the equation. So I add 2 to both sides. So minus 4 is minus 4 degrees, and it gets 2 degrees warmer is minus 2. Remember, when we add, we always go up the number scale. So 3x is negative 2. And what would I have to do to figure out what x is? I'd have to divide both sides by 3. So x is going to be minus 2 over 3. And to double check if that works, we can just double check by the next equation. So 3 times by minus 2/3 minus, and y is minus 2. So minus 4 times minus 2 should give me 6. Let's double check. We've got our calculator. So 3 times by 2/3 equals minus 2. And then 4 times by minus 2 is minus 8. Remember, when two negatives are next to each other, it's the same as adding. So minus 2 plus 8 equals 6. So using the double check, I know that I'm correct. Okay, next I have to work out the median from a frequency table. So to work out the median, there's a few ways we can do this. There's the quick way, and then there's the long way. So I'm just going to show you the long way, just in case you panic and you forget how to do it. So let's actually read from this frequency table. So there are 2 women that have a dress size of 8. So I'm going to write 8 and 8 because 2 women have that dress size. Then there are 9 women that have a dress size of 10. So I'm going to write 9 lots of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then there are 8 women that has a dress size of 12. So 1, 2, 3, 4, 5, 6, 7, 8. And then there are 6 women that have a dress size of 14. So 1, 2, 3, 4, 5, 6. Now the median is the middle number once you've arranged them in order of size. However, to find the median, the quick way, so we know that, let's say I have these numbers, 1, 2, 3. The median is 2 because it's the middle number once they've been arranged in order of size. And that is the second number. So to work out the median, what I actually do is I do the total number, or the frequency, plus 1 divided by 2, because there are 3 numbers. 3 plus 1 is 4, 4 divided by 2 is 2. So it's something that some people find really difficult to grasp, because you think there's 3 numbers, so you divide it by 2. But if you think about it with the easiest example over here, you see why you have to actually add 1 and divide it by 2 to find the middle number. So to find the median, you do the number plus 1 divided by 2. And in this case, so if we did the shortcut way, we could do 25 plus 1, which is 26, divided by 2, which is the 13th. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 13th value would be a size 12. Now the other shortcut way you could do is, if I know it's a 13th value, instead of writing all of these numbers out, but obviously do that if you've totally forgotten how to do it, then I know that I need to find out where the 13th value is. So the first 2 values are here. 2 plus 9 is 11. So the first 11 values are here. 11 plus 8 is 19. So I know that the 13th value must be in this dress size, because I know the 12th, 13th, 14th, 15th, 16th, 17th, 18th, and 19th. But you choose whichever way works best for you, but this is how we do the median. Okay, so now we have a reasoning question. It says 3 of the 25 women have a shoe size of 7. So the probability of getting a shoe size of 7 is 3 out of 25. Zoe says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 over 25, because 3 over 25 plus 6 over 25 is 9 over 25. So let's look at the, okay, so a dress size of 14, there's correct, so she's correct. So dress size 14 is 6 over 25. So the probability of getting a shoe size of 7 is 3 over 25. And a dress size of 14 is 6 over 25. And when we're working out probability, if we're working out the probability of this or that happening, then we always add the probabilities together. Because I can win if I've done that or I've done that. So it gives me more opportunities. So yes, Zoe is correct. When working out probabilities, using the OR rule, you add the probabilities. So with reasoning, you always need to work out, you always need to give a reason. You can't just say yes or no because you get no marks for that. Okay, so for question 18, we're told that Daniel bakes 420 cakes. He bakes only vanilla, banana, lemon, and chocolate cakes. Okay, 2/7 of the cakes are vanilla. So I know that 2/7 of 420 is vanilla. So I can work that out. So I know that all of the cakes, there's 1, 2, 3, 4, 5, 6, 7, and 2 of those 7 are vanilla. So to work out 2/7, I'm going to divide by 7 and then multiply by 2. So 420 divided by 7 is 60. I know that each little part is 60. And then times by 2 is 120. So vanilla is 120 cakes. The next piece of information is 35% of the cakes are banana cakes. So when you're working out percentages, 35% of 420, what I can do is I know that percent means out of 100. So that means 35 over 100. Of means times, so I could actually just use my calculator to write 35 over 100 times by 420. I could also turn it into a decimal just to make life easier for myself because you might be used to working with multipliers. Any of these methods work. So 0.35 times by 420 is 147. So therefore banana cakes is 147 cakes. The ratio of the lemon cakes to the number of chocolate cakes is 4:5. Okay, so now we need to figure out if there's 420 cakes in total and 120 are vanilla and 147 are banana, I can subtract them to figure out how many must be left over. So 420, take 120, take 147 is 153 cakes. So 153 cakes are lemon or chocolate. So I know that 153 is split into the ratio lemon to chocolate, which is 4:5. So I could just do my little parts. So that's 1, 2, 3, 4 parts for lemon and 1, 2, 3, 4, 5 parts for chocolate. So in total, there are 9 parts. So what I'm going to do is 153 divided by 9 to figure out the value of 1 part. So 153 divided by 9 is 17. So 1 part is worth 17. And I know that I need to work out how many lemon cakes Daniel bakes. So I'm going to do 17 times by 4. So 17 times by 4. And I do 17 times by 4 because there are 4 parts, is 68. So 68 cakes are lemon. Next, I have got AB, BC and CD, which are the 3 sides of a regular polygon. So regular is an important word. It means that all sides and all angles in that polygon are equal. So that's a really important thing when I'm working with shapes. And a polygon is just a word for a many-sided shape. A shape with straight sides. Okay, so the smallest polygon is a triangle, then you've got a square or a rectangle, a pentagon, and so on. So I need to show that polygon P, so this thing here, is a hexagon. Okay, so what do I know about a hexagon? A hexagon has 1, 2, 3, 4, 5, 6 sides, and if it's well, it doesn't actually say it's going to be a regular hexagon, but it would be, because over here, this side is the side of the square and the polygon over here, the 12-sided polygon. So it means that this side, and this side are all equal. So I know that I'm dealing with a regular hexagon. So a hexagon, I can figure out what the angles inside a hexagon must be. Now, when I do this, to figure out what the angles in any kind of polygon is, I start with the simplest one. I know that in a triangle, the angles sum to 180 degrees. In a rectangle, I start from one vertex, I go to each vertex, and I draw straight lines. That means I can split it into 2 triangles. So I know that the angles in a quadrilateral must sum to 360 degrees. Okay, so I can do that with every kind of shape that I have. So I've got a pentagon here. I can go across over here. So that would be 3 times 180, which is 540 degrees. So now I'm going to do exactly the same with my hexagon. I start here, I draw lines to each vertex. So as you can see over here, I can split my hexagon into 4 triangles, and each triangle has angles that sum to 180. So I can do 4 times 180, and 4 times 180 is 720 degrees. So I know that in a hexagon, the angles, all of the interior angles, so this angle plus this angle plus this plus this plus this plus this, must equal 720. Now it's a hexagon, which means no. Okay, so as I was saying, it's a hexagon, which means it's a 6-sided shape. And I know that all of the angles sum to 720. If there's 6 sides, there's going to be 6 angles. So the size of one angle is going to be 720 divided by 6, which is 720 divided by 6 is 120 degrees. Okay, so if this is a hexagon, this angle here and this angle here must be 120 degrees. So that's how I can prove that it's a hexagon. So now what can I do? Well, I know that with a square, it's a 4-sided shape. And like we said before, there's 2 triangles in there, which means that all of the angles sum to 360. But you might already know that the angles in a quadrilateral sum to 360. And if it's a square, we know that all of the angles are right angles, 90-degree angles. So I know that angle here and this angle here would be 90 degrees. Now here is a regular 12-sided polygon. So like I said before, we do the little angle trick, but sometimes it gets a little bit long if we have really, really large numbers. So we've got a 12-sided hexagon. Now, if you noticed with a triangle, so that's 3 sides, and I get 1 triangle from it. Then I have a quadrilateral, which is 4 sides, and it gives me 2 triangles. Then I had a pentagon, which was 5 sides, and I managed to get 3 triangles from it. So hopefully you see that however many sides, if you take 2, it tells you how many triangles you get. So for a 4-sided shape, if you take 2, you know it makes 2 triangles. For a 5-sided shape, you take 2, it gives you 3 triangles. So the formula for working out the interior angles is n take 2 times by 180, because n is the number of sides, and however many sides you have, if you take 2 from that, that tells you how many triangles are formed in that shape. So it's a regular 12-sided polygon. So I do 12 take 2 times by 180. 12 take 2 is 10, and 10 times 180 is 1,800. So I know that inside this polygon, all of the angles sum to 1,800. Now it's regular, which is the key word that tells me all of the angles are going to be equal. So I do 1,800 divided by 12. And 1,800 divided by 12 is 150. So I know that each angle in this polygon over here, let's get rid of some of this working, is going to be 150 degrees. So let's see what I can do there. If I just zoom into this bit here, the bit that is really important for my thing. So this I've worked out is 150 degrees. This I know is 90 degrees. And I also know that angles at a point sum to 360 degrees. And at a point just means here is my point, and these angles here, so this must sum to 360. So I can do 360, take 150, take 90, and if that gives me 120, I have shown that it is a hexagon. So 360, take 150, take 90, equals 120 degrees. Okay, so this is quite a long question. There is a shorter way that you could have done it in terms of, you know, that all exterior angles sum to 360. So 360 divided by 12 and done it that way. But I prefer the other way because it just shows a little bit of a better kind of understanding, and you can work through it that way. Okay, so here I've got a density question. So it's always helpful to just write out the formula. And density is mass over volume. So let's read the question. It says the density of apple juice is 1.05 grams per centimetre cubed. The density of fruit syrup is 1.4 grams per centimetre cubed. The density of carbonated water is 0.99 grams per centimetre cubed. Okay, so 25 centimetres cubed of apple juice are mixed with 15 centimetre cubed of fruit syrup and 280 centimetres cubed of carbonated water to make a drink with a volume of 320 centimetres cubed. Work out the density of a drink. So because I've got quite a lot of information here, it would be helpful to just do a little two-way table. So I've got apple juice, fruit syrup, and carbonated water. And then I have my drink. Now, there are three things I need. I need to know what the density is of each, what the mass is of each, and what the volume is of each. So let's see what I can figure out. I have been told the density of apple juice is 1.05 grams. The density of fruit syrup is 1.4 grams. And the density of the carbonated water is 0.99 grams. I know that the volume of apple juice is 25 centimetres cubed. The volume of fruit syrup is 15 centimetres cubed, and carbonated water is 280 centimetres cubed. So mass is like a weight, so it would be in grams or kilograms. Volume is always going to be in centimetres cubed or like millilitres. And I need to work out the density of the drink. So I can start, in order to work out the density, I'm going to need to know the total mass and the total volume. So the total volume, they've already given me. I know that that's 320. I need to work out what the total mass is. So the mass, how could I work out mass? Well, I rearrange my formula so that mass equals density times by volume. And I can just work out what the mass of each of my individual bits of drink are. So 1.05 times by 25 gives me 26.25. 1.4 times by 15 gives me 21. And 0.99 times by 280 gives me 277.2. So now I can find out what the total mass of my drink would be. So add those three together, plus 21 plus 26.25 gives me 324.45. So now I know what the total mass is and the total volume is, I can find the density by doing mass 324.45 divided by volume 320. So divide it by 320 gives me 1.0139, so forth. It says give your answer correct at 2 decimal places, so that would be 1.01. For the next question, I need to show that these triangles are mathematically similar. So to show that triangles are mathematically similar, I need to show that all the sides are enlarged by the same scale factor. So here is my right angle, and here are my 2 perpendicular lines. And this is my hypotenuse. The hypotenuse is always the side that is opposite the right angle. So 12.5 divided by 5 is 2.5. So if that's the same case for all of the other sides, then I know that it's mathematically similar. So this is the larger triangle, this is the smaller one. So I'm going to do 10 divided by 3. No, hold on. So if that's the base and I turned it, the hypotenuse is over here, and I would do 10 divided by 4. So 10 divided by 4 is 2.5. And then 7.5, this side here, divided by 3 is also 2.5. So to get from my smaller shape to my larger shape, I multiply by 2.5. And from my larger shape to my smaller shape, I would divide by 2.5. So I'd say all sides are enlarged by a scale factor of 2.5. Therefore, the 2 triangles are mathematically similar. Takes a while to write. Okay, next I have a table of values. For y equals 6 divided by x. So I could write it like this just to make my life a little bit easier, because this line here is the divisor, it means divide. So y, to work out my y value, I do 6 divided by my x value. So first I'm going to do 6 divided by 0.5. 6 divided by 0.5 is 12. Then I'm going to do 6 divided by 1.5, which is 4. Then I'm going to do 6 divided by 3, which is 2. 6 divided by 5, which is 1.2. And 6 divided by 6, which is 1. So I've got my table of values. And now I need to draw my graph. Okay, so let's just really quickly, that's 12, 4, 2, 12, 4, 2, and then 1.2 and 1. And now I need to plot this. It's a reciprocal graph, so it's going to look a little bit like a curve. So first I'm going to start by, this is my x-axis, this is my y-axis. So my first coordinate would be 0.5, 12. So I go to 0.5 and up to 12 and I plot my first point. The next coordinate is 1, 6, because remember it's always the x coordinate first and then the y coordinate. So 1, 6 is over here. Then I've got 1.5 and 4, then 2 and 3, then 3 and 2, then 4 and 1.5, 5 and 1.2. So, be very careful with the scale. So this over here would be 1. So 1.5 would actually be here. 5 and 1.2, so if that's 1, it's going up. There's 5 squares in between 2 and 1. So 1 divided by 5 is 0.2. So each little square is 0.2. So that would be over there. And then 6 and 1. And when you have any graph, unless it's a straight line graph, a linear graph, you join it freehand with a curve. So you join all of the points together like that. And that's how I do that. Next, I'm told that Harley's house has a value of £160,000 correct to 2 significant figures. Work out the least possible value of the house. So £160,000 to two significant figures is the nearest 10,000. So the largest possible value it could be would be 170,000. Sorry, if it was rounded, and the lowest would be 150,000. Now to figure out to two significant figures what it would be, I would find the halfway point. So that would be 155,000. So the least possible value would be 155,000, and the greatest possible value, I find halfway point, so that would be 165,000. So whenever you're working out the lowest and the largest possible value, think, okay, it's to two significant figures, so the nearest 10,000, so you add 10,000 on and you subtract 10,000, and then you find the midpoint between those values. Then it says the value of Rita's house increased by 5%. The house then had a value of 210,000. So her original value was 100%. I don't know what that is, but I know that 105% is equal to £210,000. So what I can do is I could figure out what 1% is. So if to get to 1 from 105, I have to divide by 105. So I do the same to this side here. So 210,000 divided by 105 is 2,000. So 1% is 2,000. And then to get to 100%, I multiply 1% by 100. So I have to do the same to the other side as well. So that would be 200,000. And that would be the value before the increase. And that's the end of the paper.